Happy New Year, folks. We're talking about Chapter 6, one of my favorite chapters. I think Chapter 7 might be my most favorite. But Chapter 6, we're talking about systems of equations. And it's really, really important that we keep with the idea that every single one of the lessons in Chapter 6 is one method to solve a system of equations. So we're going to show you several different ways to do these things, and we are going to help you out. So lesson 1 is to, I guess, give us more information about how to graph systems of equations, but to more have a better of an understanding for what the systems of equations are. So a systems of equations is a set of two or more equations with the same variables. The order pair that works in both equations is called the solution of the system. So it's an x value and a y value that will solve both of the equations. A system of two linear equations can have one, none, or an infinite number of solutions. So we can have one solution, zero solutions, or they could be the exact same line and be an infinite number of solutions. So when we're dealing with our big idea for today is the number of solutions gives us different vocabulary words or different terminology that we need to be aware of. So if I have exactly one solution, and one solution means that they're going to cross and make an intersection. So the solution for this graph is where the two lines intersect. If there's one solution, that means that the graph is consistent and independent because there is one solution. For the infinite number of solutions, we have a consistent graph, and it's dependent. So consistent means that we're going to have one or more, so that's one or more solutions, and then independent means that there's only one. Dependent means that it's going to be the exact same line. Now let's say that the lines are parallel to each other. That means that there are no solutions because they're never going to intersect, and then the terminology here is that they would be inconsistent because they do not have one or more solutions. So that's the big terminology that you guys need to understand and write down. Alright, so example 1, our job is to determine whether the graph is consistent or inconsistent, and then to determine if things are independent or dependent. So here is example A. Here's our set of two equations. We have y equals a negative x plus 1. So we're up 1 and it's going down. So that's this red line right here. And then we have a negative x plus 4, which happens to be this blue line. Okay? I'm sorry, this black line. Sorry, my color blindness got into me again. Actually, it's just stupidity. This black line right here. So these lines are parallel to each other, which means that they are just going to be inconsistent. Inconsistent. Because they are parallel and have zero solutions. Option B here for our three lines, we have a x minus 3. So that's going down 3 and have a slope here. So that's this blue line. And then our negative x plus 1 is still the red line. So that's going right here. Now our solution is directly right here. It's where the two lines intersect. I should have a different color. Okay, so our solution is at 2, negative 1. So my x value is 2, my y value is negative 1. It's a solution for this specific system of equations. But more importantly, it's consistent because there are one or more solutions. And this is something that is, again, independent or dependent. Well, it's independent of each other because they are just one solution. Now, if I knew how to spell, this would be helpful, but I'm having a difficult time on our first day back from break spelling. Independent. All right, so that's the big idea with understanding the dependence or the consistency of our graphs. Now, for just graphing a system of equations, we want to put them into slope-intercept form. So like here is our first example. We have a y equals 2x plus 3. It's already in slope-intercept form, so we remember you graph the y-intercept first, so it goes up 3. And then we have a slope of 2, because there's the number in front of x is 2, so we go up 2 to the right 1, because it's the rise over the run. Now it is super, super, super important that we go all the way through the graph, especially for these, because we're going to have a hard time finding where they intersect if we don't have a line that goes all the way through the graph. Now I just sketched it. I would suggest that you use a ruler. On the second equation, I'll do this one in red, we need to make it say y equals. So we're going to have to solve this a little bit. So we're going to go minus 8x to get the y by itself. So we're at a negative 4y is equal to a negative 8x minus 12 divided by a negative 4. And we find ourselves with a y is equal to a negative 8 divided by a negative 4 is a 2x. And a negative 12 divided by a negative 4 is a positive 3. So we have y equals 2x plus 3 for our graph. So again, we're going up 3. And then we have a slope that's going up. Oh my gosh, they're the exact same thing. So this has an infinite number of solutions. Infinite solutions. Because it's the exact same line. So all the way along this entire line is a solution. All right, let's try again. Example number 3. Graph the system and determine the number of solutions that it has. All right, so again, we're going to make it say y equals. So we're going to have to do that first. So on our first equation, we're going to subtract an x, and we're left with a negative 2y is equal to a negative x plus 4. Divide everything by a negative 2. Common mistake, people forget to divide by that negative. Then we have our equation of y is equal to a 1/2 x, because x divided by 2 is 1/2, and a negative make a positive. And then a 4 divided by a negative 2 is a negative 2. So we can graph this equation. Going down 2, put a point, and our slope is 1/2. So up 1, right 2, up 1, right 2. And we're going through the entire graph like we discussed on the previous problem. That way we can again find this one specific point or the many points that the graphs intersect. We'll do the exact same thing again here. So minus an x for our second equation. We're left with a negative 2y is equal to a negative x minus 2 divided by negative 2 on all parts of this problem. And we're left with a y is equal to a 1/2 x plus 1. So we go up 1. And notice here, folks, that we have a slope that is exactly the same. We're going to still graph it though. And we should be able to determine that because of the graph being the exact same slope, these lines are going to be parallel like we talked about in chapter 4. And when we have parallel lines, we know that the slope is the same. They never intersect, so this is a no solution. So we've shown you one with an infinite number of solutions. We've shown you one with a no solution. If we're looking at just one solution, the graph is just going to intersect somewhere, maybe like right here, and then this is the solution. You name that solution. Now we're going to have you try one on your own, and I always make you guys try the one on your own. It's a word problem. So this is the problem I'd like you to do on your own, and we will check back with you tomorrow to make sure that you know how to do things. All right, folks, good luck. We'll give you your assignment when you get to class.